Okay, so for our first lesson, we're going to introduce some of the basic trig that you learned when you took geometry a couple of years ago. So everything that we're going to talk about in this particular unit, or in this particular section, I should say, deals with right triangles. That's why it's called right triangle trig. Now, I would imagine in geometry, you probably did something with this particular phrase called SOHCAHTOA. So you learned about sine, cosine, and tangent. That's what the S, C, and T all stand for. And then I would imagine your teacher probably told you that the O's stood for the opposite side of the triangle, the A's standing for the adjacent side of the triangle, and then the H standing for the hypotenuse of the triangle. Now, what you learned in geometry was about those three trig functions, sine, cosine, and tangent. There are actually three more, cosecant, secant, and cotangent. Each of these is actually just the reciprocal of the original three. So what you'll figure out is that sine goes with cosecant. So if I know my sine ratio, I can figure out my cosecant ratio by just flipping it upside down. You can also look at it in the form of if sine is opposite over hypotenuse, then cosecant, abbreviated by CSC, is just hypotenuse over opposite. So it's the same fraction, it's just flipped upside down. Same thing is true with cosine and secant. So cosine and secant go together. So if cosine is adjacent over hypotenuse, then secant, SEC abbreviated, is just hypotenuse over adjacent. So same fraction, same numbers, just flipped upside down. Tangent goes with cotangent. So again, same thing as with the other ones. If tangent is opposite over adjacent, then cotan, abbreviated COT, is just adjacent over opposite. So again, same things, just flipped upside down. So what do I mean by all of these O's, A's, and H's? From your angle, you're going to decide what sides are your opposite side, your adjacent side, and your hypotenuse. When we label these sides, we're never going to do the right angle. We're always going to look at one of the acute angles. So this angle down here would be one of the acute angles, and so would this angle up here. So I can figure out what my opposite and adjacent sides are based off of my angle down here, which is called theta. Theta is a Greek letter. So what you'll figure out is the further we get through trig, the less and less you use letters like x and y, and we start using Greek letters like theta. Theta is just a variable. So if I want to figure out my opposite side from theta, the side across the triangle would be the opposite side. So way across the triangle, that's why it's labeled that as my O. The side directly next to the angle is my A, my adjacent. And then the side across from the right angle is always my hypotenuse. So that's how you figure out what sides are the O, the A, and the H. So for doing some practice with that, I've got this triangle down here. And what we're going to do is figure out what our 6 trig ratios are. So I'm going to figure out what sine of theta is. I'm going to figure out what cosine of theta is. I'm going to figure out what tangent of theta is. So from theta, what you want to do is label your sides as opposite, adjacent, and hypotenuse. So the side on the other side of the triangle, the opposite side would be the 12. The side next to theta would be the adjacent side, which is 5. The side across from the right angle is always the hypotenuse. And what you'll realize is we don't have the hypotenuse value, but we can figure it out using Pythagorean theorem. So if we do Pythagorean theorem, 5 squared plus 12 squared equals equals h squared, we would figure out numerically that h is going to come out a value of 13. So if you remember from geometry, your teacher might have brought up these this concept called Pythagorean triples. It's when you have a right triangle and all 3 sides are whole numbers. There are several of them. 5, 12, 13 is one of them. There's also another one that is 3, 4, 5. There's another one that's 8, 15, 17, and so on. There's just a lot of different combinations. So this is one that if you know your Pythagorean triples, this is a pretty easy one to come up with. If you don't know your triples, you can always just do basic Pythagorean theorem, and that will tell you what the third side is. So what can I do now that I've labeled all of these? Sine is always going to be the opposite side and the hypotenuse written as a fraction together. So if I look at the way I have this labeled, my opposite is 12. My hypotenuse we said was 13. So sine, its ratio is just the fraction 12 divided by 13. Cosine is always the adjacent over the hypotenuse. Adjacent is 5, hypotenuse is 13. So cosine is just the ratio, 5 over 13. Tangent is always the opposite side over the adjacent side, 12 and 5. So tangent is just the fraction, 12 over 5. 12 on the top, 5 on the bottom. Each of the other ones, notice it says the 6 ratios. So sine goes with cosecant, cosine goes with secant, cotangent goes with tangent. So the nice thing about these is these are really easy to find because all I have to do is flip the fractions upside down. So my 12/13 becomes 13 over 12. My 5 over 13 becomes 13 over 5. And my 12/5 becomes 5/12. That's how you figure out your 6 trig ratios. So what we're going to do is use the fact that I can come up with these types of things, and we're going to use them to solve some problems. Now, in each of these are just more examples of the same type of problem. So what I'd like you to do is I'd like you to do numbers 1 and 2 on your own, and then we'll talk about what the answers for them are in class. So if you have questions about how or what to do with these, then you need to attempt them first, and then we'll talk about the answers in class. So take a second and write those down. Pause the video at this time so you can write those down and then work them out yourself, please. These two you only need to find, or this one you only need to find sine, cosine, and tangent. This one you need to find secant, cosecant, and cotangent. Okay, so you're not doing all 6 for both. Okay, so again, copy those down and work those problems, and we'll talk about issues in class. The next problem is a problem that's presented like this. So say that you have a right triangle and you know that sine is 4/7. That means that if I drew a triangle and I put my theta in the corner, those two sides are the opposite and hypotenuse of the triangle. They have to be because it's the sine ratio. So if I label those two sides, my job now is to figure out what the third side is so I can figure out tangent. So if I label that as an x and I figure it out using Pythagorean theorem, we'd have a 4 squared plus x squared equals 7 squared. So some things to keep in mind about Pythagorean theorem. The hypotenuse number always goes as the c on the side by itself. And then the leg values are the ones that go on or in for the a and the b together. So 4 squared is 16. 7 squared is 49. If I subtract, we get 33. If I take the square root, I get the square root of 33. So this third side was the square root of 33. Now, you might be thinking to yourself, if you take a plus or minus, Mr. E, you said you have to put in, or if you took a square root, Mr. E, you said you have to put a plus or minus in. Well, when we're talking about geometry, we're talking about lengths. And so we're not going to measure lengths in a negative value. That's why we're only going to take the positive value when we do Pythagorean theorem. So then what can I do now with this information? Well, here's theta, and I'm supposed to figure out what tangent is. Tangent is always the opposite over the adjacent. So in this case, from theta, this 4 is the opposite side, and the root 33 is the adjacent. So my tangent for theta is going to be 4 on the top and root 33 on the bottom. Now, if you notice, none of the answers match that. The reason why? This has to be rationalized. So if I multiply top and bottom by root 33, we get 4 root 33 over 33, which then is answer choice B. So some other kinds of problems. What we'll figure out and what we learn is that you can use right triangle trig to solve for missing lengths of a right triangle. You can also use right triangle trig to find missing angle measures of a right triangle, which will be the second part of the lesson. So if I want to figure out missing side lengths like this one, if I circle my angle 55 degrees, the first thing you want to identify, what sides of the triangle are the x and the 18. The x is the opposite side. The 18 is the hypotenuse. So using our SOHCAHTOA phrase, we know that O and H goes with sine. So what we're going to write this as is the sine of 55 degrees. equals opposite side over hypotenuse. Now I'm going to leave that alone for right now. We're going to come back and solve this in a second. We're going to look at the next one. In the next one, my 35 degrees. From the 35, the 4 is the opposite side. The x is the adjacent side. So from our SOHCAHTOA phrase, we know that O and A goes with tangent. So I'm going to write this as tangent of 35 degrees equals 4 over x. Again, I'm going to leave this alone for right now. We'll come back and solve it in a second. The last one, there's my 22 degrees. The x is the side next to the 22 degrees, so that would be my adjacent. The 15 is across from the hypotenuse, or I'm sorry, across from the right angle, which makes it the hypotenuse. So from our SOHCAHTOA phrase, adjacent and hypotenuse means that we're going to use cosine. So cosine of 22 degrees equals x over 15. Now what I want you to look at is the different kinds of setups we have here. Notice in the first and last ones, we have x in the numerator. Anytime x is in the numerator, you're going to multiply to solve the equation. So in this one, we would rewrite this as 18 times the sine of 55 degrees. Same thing is going to be true over here. X is in the numerator, so we're going to multiply. So x is equal to 15 times the cosine of 22 degrees. Now this one's the oddball out. Since x is in the denominator, we're actually going to divide to solve. So this would become x equals 4 divided by the tangent of 35 degrees. So rules of thumb you might want to write down. When x is in the numerator, you're going to multiply. When x is in the denominator, you're going to divide. Okay, so you might want to take a minute and write that down. And then let's talk about what you're going to do in the calculator, because you have to have a calculator to solve these. Number one, if you have a calculator that's a graphing calculator or a scientific, it has to be in degree mode. So if you have a calculator that looks like this one, you're going to push the mode button right here, and you're going to scroll down and see how mine is flashing on radian. We can't have that. We have to click over to degree and push enter so that we're in the right mode. If you have a scientific calculator, look on your screen. If your screen says DEG somewhere on it, or it just has a D on it somewhere, that means you're in degree mode. If your calculator says RAD, or just has an R on the screen somewhere, then that means it's in radian mode and it needs to be changed. If you don't know how to change your calculator, make sure you ask me tomorrow in class and I can tell you how to do it. So now that I'm in degree mode, we're going to just type this in. 18 sine 55, and that's going to give me my length, 14.7. Please round to 1 decimal place for all of these. This one here, 4 divided by tan 35, and I get my length, x equals 5.7. And then the last one, this one again we're going to multiply, so 15 times cosine 22, and we get our side length, 13.9. All right, so moving on from just solving a basic triangle, we can also look at solving a word problem using trig. So some things. It says a parasailer is attached to a boat with a rope 300 feet long. The angle of elevation from the boat to the parasailer is 48 degrees. Estimate how high the parasailer is above the boat. So I'm really bad at drawing, but I'm going to try. So number one, here's my boat. Says you've got a parasailer being attached with a string. So here's my parasailer. Guy floating up in the air, and we're on the water. So it wants to know how high above the water is the parasailer. So I'm going to connect straight down, because anytime we're talking about a height, we're going straight up and down. And what you have here is a right triangle. So reading the problem, estimate the parasailer's height above the boat. That would be that, height. The other part that you know is my angle of elevation. So you have to think of it this way. If I was sitting in the boat and I was looking straight out, that would be 0 degrees. And if I look up, my angle of elevation rotates. So we go from looking straight out and then rotate up. So this angle here is 48 degrees. And then the rope that's attaching the person to the boat, it says is 300 feet. So this is just a matter of using a trig ratio. So the first thing you'd want to do is figure out what ratio would I use based off of the side lengths. So from 48 degrees, this is the opposite side. from the 48 degrees, that's the hypotenuse, which would lead me to use a sine ratio. So sine of 48 degrees is equal to opposite over hypotenuse, h over 300. We just talked about on the last page that if the h, or the variable, is in the numerator, you're going to multiply to solve. So 300 times sine of 48 degrees. And this is just going to be a calculator now. So we're going to go to the calculator, and we're going to type in 300 times the sine of 48 degrees. And my calculator says 222.9. And he would be in feet above the boat. So this is how you use trig to figure out missing lengths of a triangle. The next part of this, and the last part of this, is going to be how do I use trig to solve for a missing angle measure in a triangle. So the first thing I'm going to do here is I'm going to make an edit here. We're going to cross out this 52 degrees, and we're going to say that this x here is a 2. And then we're going to figure out, okay, now let's talk about what this means, solve the triangle. Solve the triangle means figure everything out that you don't know. So let's talk about what I don't know here. There are 2 angles I don't know, and there's a side length I don't know. So I have to figure out 3 things to solve this triangle. I'm going to call this side here little c, and we're going to use Pythagorean theorem to figure it out. So we're going to go 8 squared plus 10 squared equals c squared. So by doing that math, we're going to get a length of first c of 12.8. So 1 thing down, 2 to go. Now here's the deal with the next part. You have 2 angles to find. It does not matter which one you find first. If you want to find A, go for it. If you want to find B, go for it. It does not matter which one. I'm going to solve for A first. So here's how I'm going to do it. I'm going to look at the numbers that I was given in the problem. The 8 and the 10 are the opposite side from A and the adjacent side from A. Since I have opposite and adjacent, I'm going to use a tangent ratio. So I'm going to take the tangent of angle A, and it's going to be equal to opposite over adjacent, 8 over 10. Now here's the deal with your calculator. When you look at your calculator, you'll notice that there are actually 2 sine buttons, 2 cosine buttons, and 2 tangent buttons. One of them just says sine, S-I-N. Right above it, though, in yellow here, it says sine with a little -1. That's called sine inverse. Anytime you want to find an angle measure, you're going to use an inverse. So this one is set up with tangent, so we're actually going to use tangent inverse. So the way we're going to rewrite this, so I can enter it in the calculator, is we're going to take the tan inverse of that ratio. So we're going to write this as A equals tan inverse of 8 over 10, and we're going to type it in the calculator exactly like that. So we'll push second tan. That's how you get the little -1 to show up. And you're just going to type in 8 divided by 10, and it will give you the angle measure. So this is a degree to the nearest tenth would be 38.7 degrees. The last part then is to figure out angle B. There's actually 2 ways you can do it. You can write another trig ratio to figure it out. So you could do tan of B equals 10 over 8 this time, or you can simply just know your properties from geometry. That, and that all have to add up to 180 because it's a triangle. Even further than that, since this is 90, B and A have to add up to 90 because there's 90 left to split between the 2. So angle B is as easy as just taking 90 degrees and subtracting off letter A that we just found, which is exactly what I'm going to do. And so we end up with 51.3 degrees. The next problem is not going to be really any different other than, first thing we're going to do is find y. So in this case, we would do y squared plus 2 squared equals 4 squared. So doing some math, we do 4 squared, subtract 2 squared, and we're going to take the square root. So we end up with a length of about 3.5. So one thing down, 2 to go. You've got 2 angles to find. Again, it doesn't matter which one you find first. I'm going to find x. So from angle x, what sides are the 2 and the 4? The 2 would be the opposite side. The 4 would be the hypotenuse. So using our SOHCAHTOA phrase, O and H would be sine. So I'm going to take the sine of angle x, and that's going to be equal to opposite over hypotenuse, so 2 over 4. And we're going to find out that angle x, using my calculator, is going to be found by doing sine inverse of 2 over 4. And that angle is going to come out to 30 degrees. If I want to figure out the last angle, it's as easy as just taking 90 degrees, subtract the one that we just found, and your y, angle y, comes out, oops, not 30 degrees, 60 degrees. Make note of any questions you have about these, and we can discuss them in class. And then the last thing is another word problem where we're going to solve using an inverse. So let's talk about how to do this one. It says a ramp has a length of 20 feet, a vertical rise of 2.5. Find the ramp's angle of elevation. Now, if you think about a ramp's going to look like a wedge. So it's going to look like a right triangle. And all we're going to do is label the sides, find the angle at once. It says the length of the ramp is 20 feet. So do I label it on the hypotenuse or do I label it on the horizontal length? Label the hypotenuse, because anytime you see that a ramp length is 20 feet, you have to think, what would I physically be walking on? You'd be walking up the slant, which means that that ramp is 20 feet. The vertical rise is 2.5 feet. And we're supposed to figure out the angle of elevation. So from straight out up, what angle would that be? So I'm going to label it as theta. And we're again going to use a trig ratio. So looking at the sides, 2.5 would be the opposite side. The 20 would be the hypotenuse. So this one again is going to lead us into using sine ratio. So we're going to go sine of theta equals opposite side over the the hypotenuse. So 2.5 over 20. In my calculator, since I'm figuring out an angle, we're actually going to use sine inverse. I'm going to write that first. And then once that's written, it's just all calculator. So we're going to go to my calculator and do second sine. That's how I get it to have the little negative 1. 2.5 divided by 20, close the parenthesis, and we end up with a final value of 7.2 degrees. So that's the end of the lesson. So make sure you make note of any problems that you had issues with. And then remember also, I asked you to complete these 2 problems where you're just figuring out sine of theta is this fraction, cosine is this fraction, tangent is this fraction, and the same thing with this one. Secant is this fraction, cosecant is this, cotangent is this. Anytime you're asked a problem like this, the answers for each of these are just going to be a fraction, whether it's opposite over hypotenuse, adjacent over opposite, whatever it happens to be. So we'll talk about those when you come to class. Just a little bit of a hint, you're going to have to figure out those 2 lengths in order to do all 6 of these. So write down questions and we'll talk about it next class.